Hey everybody. So today I want to talk about a subject that I see come up a lot, but I don't see a lot of people actually address or make videos about or talk about, kind of like on a broader scale. So let's talk about it. And that's the issue of model decay, specifically LLM model decay. And then if you don't know exactly what I'm talking about, let me give you some real quick examples in real time by using Google here. And then so I'm just going to essentially search for, let's say, for example, model degradation, model performance decrease. I'm going to say GPT-4 and I'm going to say Reddit because that's just, it's just easy. So, and then here's a bunch of results, right? So 4 months ago, with all the reported degradation in GPT-4's performance, OpenAI, can you explain the decreased efficiency in GPT? GPT-4 has only been getting worse. Has anyone noticed a decline in GPT-4's performance? And we can see that these occur at like various points over time, right? Every day that passes by this post about GPT-4, performance decline becomes more and more obvious. What can be done? This is 4 months ago. 9 months ago, for people who keep asking if GPT-4's performance. So this is a study suggesting that it has decreased over time, etc. Right? And then I can Claude 3 Opus is the latest model, right? 3 Opus performance decrease. Noticeable drop in Opus performance. Claude 3 gotten worse since release. Have you noticed any decrease or degrade? That's people talking about these subjects, right? And then so essentially the first thing is what exactly is this? The first question I think that we should ask is there a precedent for this? And then the answer to that would be yes. There actually is a lot of precedent for what the situation could be, and what I'm going to call it if we actually look into it. And so I'm going to call it model drift, right? And then so, which is what it is. And then so model drift is the decay of models' predictive power as a result of changes in real world environments. It's caused due to a variety of reasons, including changes in the digital environment and ensuing changes in relationship between variables. And then essentially the bottom line with model drift is that this is a concept that's not new at all, right? Model drift has existed in well before LLM models, and then this is with regards towards predictive models very specifically, right? And then so, and especially like with like GANs and other types of models, like all types of models, this particular problem has existed where, and that you train a model up to like, say like even like 99.9% accuracy, and then over time that accuracy degrades and degrades and degrades, and it drifts from the original results, right? And then so within that, there's a few things that you can do to like solve for model drift. Like you can rebuild the model, you can retrain the model, etc. But the thing is that like this problem is not new. And then so when it comes to the question of LLM models, we kind of come to like a new problem in this particular instance. And then so I think that this particular chart here that we're looking at in this instance gives us, I think, the best representation of what we can be looking at in this instance with regards towards models. And there's a few things that I want to point out here. The very first thing is that you can see that this starts pre-2020 and then it goes up to the modern day. And then if we go to pre-2020, we're getting off the chart on the bottom side of the chart, right? And then so what that means is that these models were off the charts small in this instance. And then so the smallest models at the like kind of bottom of this chart are 1 billion parameters. So this chart goes like to about 800 million parameters, let's say, as the bottom threshold. And then we can see that pre-2020, everything is below 800 million parameters, well below 800 million parameters. And then 2021 is GPT-2 and T5, and then 2020 we've got Megatron at 1 billion parameters, right? Megatron, and then so like which is massive at the time, like huge. It puts it onto these charts, and then from there we've advanced and gone up significantly in number of parameters, like hugely in number of parameters. And then so the thing that I want to point out with this is that so it's been known that model drift exists if you're operating like well below this, right? Like below, if you're off the chart below, we know that model drift can happen. If you're off the chart above, we have less data to work with overall because we have less of a timeline to work with overall, right? So like, does model drift affect models that are high in parameter more or less than models that are severely low in parameter. And we don't know, like, there's not enough data at this point. Like, I can go back from, it's like 2015, 2017, like a lot of data with regards towards model drift overall, and it would all be applicable to smaller models, right? But then, like, model drift towards these bigger models, what I started off this video with, that's the, like, most of the research that exists around this. There's a few academic papers that are starting to come out around, like, that are more recent around model drift, and then there's, like, a lot of it is solving for model drift or trying to solve for model drift, though, and then it's not, like, directly, like, asking questions around, are big, huge parameter models more or less prone to model drift? Like, that's a pretty big question to me, right? And it seemingly, to me, with the limited data that we have so far on this topic, they they are very prone to model drift. They don't, like, there's nothing to me that it makes them magic with regards towards this particular problem. Like, so if this problem exists in smaller models, it exists in larger models unless someone has specifically solved it, and there's not a research paper that exists that says it's been specifically solved in large models, like 100% across the board, and only large models, right? Like, I haven't seen that. And then again, the question hasn't been asked of, are large models more or less susceptible than their smaller model counterparts to this particular phenomenon? And we don't know scientifically. Looking at the general consensus of the data, there seems to be an argument to me that there's at least there's at least some chance that model drift is higher in these and more prone in these higher parameter models than it is in the lower parameter models. And then, so in that instance, we need to see more retraining and more rebuilding, which we see often, right? Like GPT-4 was just recently rebuilt in November, and then so now this would be the time where we're starting to see model degradation again, and then, like, we're starting to see that come up, right? Like, it's like every 4 months or so seems to be a common pattern. Like, where, like, we need to address these problems. And then, like, I mean, I don't think it's coincidental that this model called ChatGPT 2, if you know anything about the mysterious ChatGPT 2 that is circulating around right now, like, that it's a model replacement, right? And it looks to me like it's some sort of retrain of GPT-4. Like, that's what it looks like to me. Bottom line right now is what ChatGPT 2 is, and, like, if it is, that makes complete sense, given the timelines, because we're starting to see performance degradation again, or model drift, with regards towards GPT-4. So it's time to rebuild it again and time to retool it again. And then, so I guess ending this, what does that mean overall? Like, it means a lot, and it means a little. Right? It means a lot if you don't retool and or retrain your models. If you don't do that, then the models kind of are like garbo, right? Over time. And then the second thing is that we need to evaluate and put more academic research behind these particular questions of how exactly this model drift is affected and on these models, specifically in this larger parameter bracket where we have a lot less time frame and research around than we do in other models. And then, so I think it'll be interesting over time to see how this shakes out overall, and then to see exactly how companies deal with this problem. But the bottom line is overall that it's an expensive problem to deal with, and I think that's probably the perfect ending point for this video here is that when it comes to dealing with this problem, it's an expensive problem either way, right? It's expensive to train these models, it's expensive to retrain the models, and it's expensive to rebuild the models. And then, so that is a moat, right? It's very significantly, like, as long as these much higher parameter models are performing much better on general than their lower parameter counterparts, it's a moat to be up there and to be expensive enough to be able to play in that game overall. And then, so until somebody, so I guess that also disincentivizes every single player in this market as well to come up with a long-term solution to this model drift problem as well, right? Because it's maybe like that incentivizes the players that can build these models up here for model drifts to occur more for models up here, because it wipes competitors that want to play in this game that can't necessarily afford it as much. So it creates a lot of interesting dynamics overall, just beyond like the research areas is what I want to highlight and showcase with this overall at the end. So if you like this type of content, please like and subscribe. Thank you very much.